Hello everyone, how's it going? My name is Dan the Tutor. Today we're going to be talking about sound intensity and the unit of measurement for sound intensity, which is the decibel. Some of you may have heard what a decibel is before. I'm surprised always, every semester, so many of my students have no idea what a decibel is. They've never heard of it in their life, but it's just a way of measuring sound. So first, just to give you an idea of some common decibels that you should know. On one end of the spectrum, 0 decibels, this is like you can hear nothing, like you can't hear anything. Then on the upper end of things, I'm going to stop at 120, although technically sound can really be as loud as anything. But the reason I'm stopping at 120 is because this is called the threshold of pain. In other words, once you get to 120 decibels, your ears start hurting. Imagine a screaming child in your ear. That's around 120 decibels. And right around 60 decibels, although it depends how loud you are, 60 decibels is considered like normal volume. So if you're having a conversation with a friend and you're both, not trying to whisper or anything, you're probably talking around 60 decibels. I'm probably around 65 right now. But that also depends on what volume you're listening to, so that's not exactly 65. And by the way, technically, you can get quieter. You can even get down to negative 10 decibels. And the reason why you can have negative decibels is because 0 decibels just means you hear nothing. It's too quiet. Negative 10 decibels means that you can't hear it, and it's even quieter than 0. So imagine someone talking on the other side of the world. Even though you can't hear it, their sound technically has an intensity to it. You just can't hear it because you're so far away. So that would be an example of like a negative decibel reading. But don't expect to see that in class. That's kind of a weird example. Now let's talk about how to convert intensity to decibels. So there's 2 conversions we need to know. First, if I give you intensity and you want to know how many decibels that is, you would say the number of decibels is equal to 10 times the log of I over I naught, where I naught is known as the threshold of hearing, and that has a value of 10 to the minus 12th power. Very small. The threshold of hearing is basically saying any quieter than that and you can't hear it. So that's like the 0 decibel mark. Now, you'll notice that this log does not have any base to it. That's because that's known as the common log, which means it is log base 10. Or you can just hit the log button on your calculator and it will do the same thing. And by the way, this is more of a fun fact. You know how there's centimeters, kilometers, and then there's like those other prefixes, like for instance, decimeter? Well, the prefix deci means multiply by 10. And so that's where this 10 comes from in the equation. Whatever your sound is in bells, you just multiply by 10 to get to decibels, or decibels. And the reason why we use decibels instead of just bells is because, well, frankly, I don't really know why. But that's the system we agreed upon, us physicists, when we met behind our secret boardrooms and we decided how to rule the world with physics. We decided to go with decibels, multiply our answer by 10. And so just take my word for it and don't question it. So an example of this would be, let's say I have an intensity of 3 times 10 to the minus 6th power, and I have no idea what this is as decibels. So let's convert it. The number of decibels is equal to 10 log of, in parentheses, numerator is 3 times 10 to the minus 6, denominator is 1 times 10 to the minus 12th. The reason why I'm saying 1 times 10 to the minus 12th and not just 10 to the minus 12th is because when I plug this in my calculator, my TI-84 graphing calculator has a cool little E button, which is for scientific notation. So I'm going to do 3e negative 6 divided by 1e negative 12. I don't want to do 10e negative 12. That's not scientific notation anymore. Or if you don't know what I'm talking about with this e stuff, you don't need to do it. But believe me, it's a lot easier than plugging the whole thing in your calculator. So then after I plug this in my calculator, I get 64.8 decibels. And hopefully you got that as well as your answer. And if not, you did something wrong. Now let's say I want to do the opposite. In other words, I give you the number of decibels. I want to know what intensity that is. So for that, we use the equation I equals 10 to the power of the decibels divided by 10, and then times I naught. Remember, I naught is 10 to the minus 12th, or 1 times 10 to the minus 12th, whichever you prefer. So in that example, if let's say I have 120 decibels, which remember is the threshold of pain, let's see what that is as an intensity. So that's going to be I equals 10 to the power of 120 over 10 times 10 to the minus 12th power. If you plug this in a calculator, you'll get exactly 1. And the units for intensity, by the way, are the watt per meter squared. I don't know if you have to know that or not, but I do, so I'll tell you. So now let's look at an example problem. Let's say you're talking to one friend in a room, and that friend is talking with a decibel rate of 50 decibels, let's say. What I'd like to know is, now let's say 4 of your friends are now talking all at the same time, not including you, and I want to know how many decibels is that? Very common question. The first thing people do is they just take the decibels, they multiply it by 4, and you get 200 decibels. And this is the wrong answer. Let me explain why. Because when you're talking with 4 of your friends, do your ears explode? The answer is obviously not. Now, why do I put it like that? It's because we just said earlier that the threshold of pain is 120 decibels. So 200 is way past that, and assuming your friends don't talk as loud as jet engines, I have a feeling that this is the wrong answer. And why is that? Because if you want to add these 4 friends' sound level together, you never add in decibels. You always add intensities. So what that means is I got to convert 50 decibels to intensity and then multiply that answer by 4 and then convert it back to decibels. So let's go ahead and do that. It's not actually as bad as it sounds. The intensity is equal to 10 to the power of decibels, which is 50, over 10, times I naught, which is 10 to the minus 12th. You plug this in a calculator, you will get 10 to the minus 7th power. And again, this is just for one friend. Now, if you have 4 friends, I'm going to multiply this answer by 4. So it's really 4 times 10 to the minus 7th power. That's for 4 friends. And then finally, I just have to convert this now to decibels using the decibel equation. Decibels is equal to 10 log of intensity, which is 4 times 10 to the minus 7th, divided by I naught, which is 10 to the minus 12th. And if you plug this in a calculator, then you'll get a decibel reading of 56 decibels. So in other words, one friend talking was 50 decibels, 4 friends talking, it goes up to 56. You'll notice it's not that big of a jump. And as a matter of fact, if you want to go up by 10 decibels, that means you're 10 times as loud. So what I'm saying is from 50 decibels to 60 decibels, that is a difference of 10 times louder. And if you go to 70 decibels, that is another 10 times louder. And as you can see, by the time you get to 120 decibels, it's not just 10 times louder, 20 times louder. The jump is 10, then 100, then 1,000. It's probably 1,000,000 times louder than 60 decibels or even 50 decibels, right around there. Now we're going to do one more problem. This one will be challenging. Let's say we have an intensity of 3.5 times 10 to the minus 8th power. That's the first intensity. The second intensity is, let's say, 5 decibels louder. I want to know what is that second intensity in terms of watts per meter squared, which is the units for normal intensity, not decibels. So this one, why don't you pause the video, think about it for a second, and see if you can get it. The one thing I want to warn you is that the solution is not something we've done yet today. Okay, so I'm assuming you gave it a try. Now here's the solution. The thing is, you really cannot mix and match decibels and intensity. So when we say something is 5 decibels louder, it means that we need to be talking about decibels in order to compare the two. So what I'm going to do is I'm going to take the intensity we started with, 3.5 times 10 to the minus 8th, and convert that to decibels so that we can then basically add 5 to it. Now, just so you know, if you did it the other way around, if you converted this to an intensity and then added the 2 intensities together, you will get the wrong answer, unfortunately, and you'll see why after we get this answer. But first, let's convert 3.5 times 10 to the 8th to decibels. Decibels equals 10 log of 3.5 times 10 to the minus 8th divided by 1 times 10 to the minus 12th. I plug this in my calculator and I will get 45.4 decibels. And now we're saying the second sound is 5 decibels louder. That is when I'm allowed to add 5 decibels. I can only add 5 decibels to another decibel. So the answer I get there is 49.4 decibels. And now we just have to convert this back to an intensity, and that'll give us our final answer. So the intensity I is going to equal 10 to the 49.4 divided by 10 power times I naught, 10 to the minus 12th. And we will get an answer of 1.1 times 10 to the minus 7th. And that is watts per meter squared. And there's our answer for that one. So that's going to do it for today. Thank you all for watching. I hope you learned something new. If you still have any questions, please post them in the comments below. And I'll see you in the next video. Take care, and bye-bye.